What's going on, everyone? Welcome back. This is Giovanni, also known as CryptoJo11 if you follow me on Twitter. This week we're going to resolve with a little bit of delay, as I'm being very busy with other things, we're going to be resolving the week 4 homeworks for the Plutus Pioneer Program. This week the homeworks are actually not too lengthy, so hopefully if I get it right, it will not take too long. Because we've seen a lot of the monads, on which I have a different video that hopefully I will be linking probably here. That is about how to think about monads rather than try to explain what monads are. Because at the end of the day, we have to use them. I know that it's important to fully understand what they do, but if we start to use them first, it gave us a sense of what they're really useful for, and then if we understand how can we use them, we start to take straight into our head what they are, and so understanding them without very strong mathematical background or category theory background, we can intuitively understand what they are and of course how to use them. Before beginning, I just want to remind you that if you like the content of this video, and in general of the tutorials and extra material I'm preparing for the Plutus Pioneer program, please delegate to my stake pool that has easy1 as ticker. Right, so without further ado, we switch into the ID view. As you can see, I'm not using IntelliJ IDEA anymore, but I'm using VS Code for a simple reason. Upon a suggestion of a colleague of mine that actually uses Haskell every single day, ciao Alessandro, he recommends to use VS Code because it has a very nice plugin that you can see is integrated with Cabal, while it looks like IntelliJ IDEA has a better integration with Stack, that is the equivalent probably of Maven for Haskell. So if you ask me, this is much nicer because I can actually inspect, type, and have some suggestions as I'm typing, because that's what I've been used the whole life. So there we are. Anyway, today what we have to do is to implement this pay trace, and basically what we have to do is simulate a user making twice a transaction with two different amounts. Because while the first one on paytest 1 everything will be fine, because by default the wallets that have this amount of ADA as they get initialized, the second time around it will bomb out. What we have to do though is to prevent the smart contracts off chain to explode, throwing an error by wrapping the payment transaction in a sort of try-catch, if you will. Just capture the error, print a message on the console so that we can inform the user what the hell is going on, and then still make the second transaction to happen. This is arguable whether or not it is ideal, but for this specific exercise, we want the second transaction to happen regardless of the outcome of the first one. So let's not think about what should really happen in real life, where maybe we want the second transaction only to happen if the first one was successful, but for the purpose of this exercise, we want the second one to happen after the first one, regardless of the outcome. Right. So just to anticipate that. Nothing. Let's dive right in, and then we add some further consideration down the line. So the first thing that we have to do, we have to create a do block. This is because what we have to do is we have literally to flat map or bind multiple operations one after the other, and only get to the very last one once that all the other one have successfully completed. So we start from the first one because the first thing that we have to do is to initialize the wallet. What we do is we start to write the method. Is nice that the idea, so VS Code is actually giving me a suggestion. So we want to activate contract wallet. As you can see here, there is also the type signature, the method signature that is really long, but the most important thing is that it requires a wallet, and then it returns a it returns a contract. So let's start to write this thing out. Activate contract. Sorry, there was the wrong method. This is the correct one. Activate contract wallet. Or maybe I was showing the same. Anyway, doesn't matter. So we start with this one. So we need to say what the wallet is. So we put parentheses and we call it wallet1. That is the wallet that needs to trigger the operation, and the contract. The contract, we actually have it already. That is pay contract. Now, as you can see, there is a type error here. This is because I'm returning the monad rather than capturing the handle into a variable. So here we are. This should now turn green, I think. Okay, no, this is still red because this is actually not the return type. So what we do now is that I would say to just give it a weight. So we use C emulator, and then we say weight and slot. We just wait one slot. What we have to do here, I think, though, is what is the return type? This is just a slot, so we have to void this one because we have to ignore the return type. And now what we have to do is we have to invoke a method. We actually have to call the handle and make an to trigger the payment, the contract payment. And we do this by calling the call endpoint. What we have to do here is the contract handle. The first thing is that we have the handle, but we need to call a specific endpoint. That is the @pay. So it's going to be @pay of h. That is our handle that we just got here, and then we have to pass the parameters to this endpoint. That, of course, is the pay param object. That is going to be something like this one. We have to pass the recipient. That is going to be, let's see if I remember this one. This is pub key hash of wallet address of wallet. Remind me something. Wallet 1, so wallet 2, and I think I can do this. What address wallet 2? This one should work, and then I need the amount of Lovelace. This one instead is easy because we want that it needs to be equals to x. What does this one want? And so there is a type mistake here. Pub key, wallet pub key. Oh, wallet, and wallet is wallet too. Sorry, that was a type mistake. So pub key hash wants a pub key and returns a pub key hash. So we need the pub key. Wallet pub key, it needs a wallet and returns a pub key. So this one is type matching again. So we wait another slot to make everything to happen, and then what the code wants is to do exactly the same thing again. And we run the emulator and we wait for everything to happen. I don't think the last wait is necessarily, oh sorry, there is like a little mistake. This time around we want to pay y, that is the second one. I don't think that the last wait is strictly necessary. I'll just put it there, it won't harm. Just waiting for yet another block to be minted. So I save and I'll go into my Cabal REPL. I hope I have all the dependency already ready to go. Cool. I'm gonna load the module that is source week 4 and then is homework. And it loaded. So let's go back, and there are the two methods. This is paytest1 and paytest2. So paytest1 should just work and everything is fine. We can see that we get them how much was that? 1 million Lovelace plus 2 million Lovelaces, and we see that there are 3 million Lovelaces minus the 20 Lovelace paid for the transaction. But then if we do, everything is fine here. You see that the contract has finished without any error. There is the call to the endpoint, the string is pay, the name of the endpoint is pay, and then everything looks good. And then we pay now test 2, and let's see what happens. Here we see that there is actually an error. The contract stopped with error. So what happened here is that we tried to pay insufficient funds. The error message is quite self-explanatory. Yeah, that didn't work. So what we have to do is to wrap this thing into kind of an exception manager. So the way I initially solved this thing was to follow pretty much the same approach as Professor Lars into the classes. So what I did was to create another method called safe pay contract. And this has exactly the same signature as actually I'll write it. The same signature as the previous one. One is contract. The first one is contract, the second one is void, and then pay scheme again. For the capabilities, this time this one needs to be void because we are not returning any message, and then the return type is unit again. So let's implement safe pay contract. This one is nothing else that the same way that Professor Lars resolved into the class. So I have contract, and there is one method called handle error. Then there is a lambda that says what I want to do with this, and it simply is log error where I'm saying error, saying plus show of e. And I think I have to do something like this to make this thing to work. And then basically what I'm doing is to, now look at this. What I have to return here is a contract, right? So remember this thing. This is important because contract is actually the monad contract, right? So on a second thought, I think there is a better way of doing this. Instead of creating another method here, maybe we can do this one a little bit better. So, but for the moment, we say that a safe pay contract is nothing else than a contract handle that returns a contract. You can see it here. And the contract that we're going to pass is nothing else than the pay contract, right? So we do this. What's the error here again? Do I have to put this one? Yes, much better. That's the lambda. Do everything. Now void, it tells me that it's not included. What we need to do is to import data void. There we go. And that should be just void here. Do I need this one? I think this is okay. Let's ask. Let's yeah. So and then instead of calling pay contract, what I have to do is to put safe pay contract here, because now this is basically the safe version of the contract. It's exactly the same contract as before, but we are adding these extra capabilities here. So this is like an overarching bind that says bind this one to everything else, but if there is an error, basically wrap into it. So I'm gonna save and I'm gonna reload the module. Let's see if everything is fine. There is just like some redundant thing, but don't care. It's fine. So let's say pay test 1 is still working fine. Pay test 2. So we now see that there is a contract log error, but the contract is stopped without error, so completed successfully, right? So everyone's happy. The problem is solved, right? So this could actually be a good solution that will resolve the exercise. We've seen that everything is working, but is there a way that because we are just creating a chain of binds, we are binding multiple contracts one after the other, and we are here just passing this contract here. Is there a way we can take this command and embed it into this block so that we will have one less method? I think we can, and we have to try to understand, figure out what is the piece of code that is actually blowing up and throwing an error, and we have to wrap inside this this handle this handle method, this handle function. So here we're simply calling the endpoint. Then here we are building the transaction. And then here we are submitting the transaction. So I think that the error is happening here in submit transaction. So what we have to do is handle the error around this method call. There are a couple of things that we have to think about. First of all, because pay contract is already a monad of type contract, whenever we actually I've done a mistake here. I could have written straight away and handle error straight away. We can prevent from writing contract dot because we are already inside the contract monad, right? So we can write this one straight away. And the second thing that we have to think about is that here we are using void. So this show will not work anymore because it's a different type when we move it up in the other method. So let's do this. Another thing that we have to be careful about is this void function used here. So we are using the void function because we are basically throwing away the result that we are not interested into, and we are basically just returning the same contract as a result of this function. So whenever we embed the handle error, we have to insert it here and then just concatenate the two things. So now the show is not working anymore, but what we have to use in order to transform this string into a text is that we have to replace show with unpack. And unpack is basically unpacking a text, and in this case this is the text that we want to unpack. So we can now comment those two lines. Of course, a safe pay contract does not exist anymore, and we have to just replace with pay contract. Also, void is not used anymore, so we can delete it, save, and rebuild the project. Boom, it's compiling. So let's try pay test 1. Correctly working. Let's try pay test 2, and it's correctly working. Oh, there we go. There is the error. I couldn't find the error. There we go. So insufficient funds, but the what's it called? The contract is not suspended or terminated in error. Before wrapping up this thing, this video, I just want to spend literally 1 minute talking about the structure of the do block here. If you check what endpoint is returning as a return type, it's returning a contract, right? And the same thing is doing submit transaction. It's returning a contract, but in this case, the type is transaction here. So, but now you see that we are using the arrow, left arrow operator to basically unwrap the monad and extract the value. So, and if we cared really about the result of the handle error, we would have had, I don't know, something here, and we would have extracted from the monad as well, and then we would have done something with the something. But we don't care about something. But for a second, let's let this thing run here. But what if we need to call, or we need to use something that in this loop we need to we have to do something that an operation or call a function that is actually not returning a monad. So the way we do this is with let. It's very important to understand that at the beginning, inexperienced people will try to do something like transaction and then arrow and must pay to pub key, and then there's going to be an error that says must pay pub key is not of type it's not a monad of type contract. So how can I extract the value from here? So this is something that inexperienced developers or people that don't have like lots of experience. So I've done this a billion times, and this is the only reason. This is the first reason why I'm saying this, because I've been doing this myself before. And I was like, right, I need to call something in this chain of action, but in this chain of action, I need to do something that is not exactly a monad of the type that I'm actually chain binding. So how can I do this something as part of the chain, but it's not actually a monad? So the way you do this is by just using let. So let allows you to do something that is not part of the binding of the different, in this case, contracts that we are concatenating one after the other. We are still doing some sort of concatenation here, because must pay to pub key actually requires this value pp that is coming from the endpoint call, right? But it's not monadic. It's not a monad itself here. It's not a contract. This is something that happens with the result of this endpoint function call, but it's not a monad per se. Yet we can concatenate this thing into a flow of bindings on contracts. So just let's recap. This is let's recap. This is like a contract of something. So we are basically and we are doing the bind on this thing. So we're doing bang. In this case, this one, it's not a contract, So we are not calling basically the bind, but we are simply executing this without being in contract. This is still concatenated, and this will not, technically should not fail unless of runtime issues. And then after this one execute, then this other bind is executed, because submit is a contract. So basically we are doing the PP here, bind submit transaction, and throw away the result. So we've done two bind and an initialization here, and then we're just returning the contract. So do remember that if you need to concatenate, if you have a concatenation of different monads, but at one of the steps you need to do something else that is just like a simple operation, and it's not of the same, and it's not a monad of the same type. It's not a monad actually. It's just a call function, and you need that return. You can just do this. Define the variable, do the function, take the return, and pass it to the next step. So, excuse me. This is basically how to blend binds or flat map if you come from Scala, for instance, but at the same time you need to instantiate a variable that is depending on the previous step, but it's not a monad per se, so you can't call flat map on it, or bind in this case. So, and with this, I really hope I kind of explained this thing, because it's really important to have this concept in mind. So I really hope this is going to be of any use to anyone. So with this, I am actually going to roll back all the changes. I thank you very much. If you have any questions, if you have any feedback, if there is anything you want me to talk about, please reply into the comments below, and I'm going to try to make another video and give more explanations. Thank you very much. Have a great day, and I'll see you on the next tutorial. Bye bye, and good luck with your homeworks.